Hi, good morning, everybody. So, we are here to talk about something that's in top of mind for all of us. How do we build data platform that not only handles the complexity of today's data platforms, but also unlock the immense potential of data? So, we are going to explore how we can move beyond our current limitations to step into a future that is more unified and intelligent data future. Hi, I am Shivani. So, I'm onboarding engineer from Starburst. In the past, I've done multiple hats, starting as a data engineer and an implementation engineer here at Starburst. So I'm very excited today to tell you about how we can empower ourselves to lead this transformation. Okay, we all know the data drill, right? So we all have the enterprise data siloed and fragmented across different data sources and making it extremely difficult to access this data. So what the ETL does is that it tries to skim through all this data, churn huge amounts of data, and try to move into a warehouse. So when we do that, it creates a single source of truth. But with this, the data is often siloed, outdated, and fragmented. So we are not even ready for what are the growing needs of data science and AI, which actually needs to process a lot of unstructured data, creating a lot of multiple copies of the data using, again, adding a layer of complexity on top of it. And this also creates multiple copies of the data, which also creates inconsistencies as well. So don't even started about managing these data sources and governing these data sources. It all feels like a maze, right? So yeah, so the future of the data that we all want is something that is open data stack. So for us, the data engineers and the data folks out here, that the future data platform would hit just that sweet spot where it has the abilities of perform a warehouse without the cost price attached to it, right? And also it gives you the option to use one your favorite tools, all your open source favorite tools, right? So at the same time, you don't have to worry about the complexity of moving the data at all. This all makes sense, right? So what we are aiming at is not having just a lakehouse, which you already have, but actually having an open hybrid lakehouse. So to start with the open hybrid lakehouse, how do we build one? So what we need to start with is an open query engine, that is Trino. So Trino is that engine. For those who is not aware of Trino, what it does, Trino is the massively parallel distributed SQL query engine, which is open source. It was originally developed at Facebook for running data at petabyte scale. It's also known for querying data across multiple different sources, that is called as the query federation, eliminating the need to move complex data around and writing scripts, right? So it also has the design so that it can separate your compute and your performance, you compute and your storage, so that you can scale both of this independently without to make sure that you save on the cost and utilize your resources effectively. So open architecture of Trino is also one of the reasons why Iceberg, the leading lakehouse table format, was designed to work with Trino. So with proven success at one of the world's biggest companies like Netflix, Meta, and Pinterest, which use Trino to run data volumes such as really high data volumes at petascale at really high concurrencies, all backed by an open source community of 750 plus contributors. So this brings us to Starburst. The first thing I want you to know is Starburst is a Trino company. Co-founded by the creators of Trino, we bring the goodness of Trino to the enterprise. All the goodness without the hassle of maintaining these platforms for you. And we are the #1 contributors for Trino, and also we house one of the largest teams of Trino experts. Now, let's see in detail what are the different features that Starburst brings into the picture. To start with, Starburst is the analytics engine that fits into any environment without making any changes to your existing environment. This brings all the advantages of Trino with the additional enterprise-based features that makes an actual difference. With the massively parallel query engine, which is actually the Trino's query engine, which can parallelly scale and process your data at a petabyte scale efficiently. And we also have data products which actually help you to curate your data sets, govern them, and make sure they are always up to date. And with the fault-tolerant execution mode, which is specifically designed for ETL workflows, make sure that your queries always run effectively. And then with the query optimizer, which optimizes the query way before it runs so that it knows what is the best way to run your query and what are the resources it has to utilize. And starting with auto scaling, so as we already know, Starburst auto scales from gigabytes to petabytes in no time so that you can save on your resources. And also when smart indexing and caching are enabled, you can see a significant difference in the query times. All this combined with metrics and logging features, which make sure you have the entire view of the data and your data platform. So Starburst acts like a central hub for all your data sources. You can plug into it and query any data source that you have. So your data can be a data lake, relational databases, NoSQL, as well as a real-time data sources as well. So this creating a kind of a data mesh for your data sources. This actually breaks down the silos that we talked about earlier of fragmented, siloed data into a true sense of single source of truths. Plus, we have all your favorite BI BI tools that you can easily integrate with Starburst without any changes. Now, let's see what we have in store for data engineers at Starburst. First of all, imagine a place where you don't have to write heavy ETL scripts and move the data in and out and have to spend hours just waiting for the jobs to complete. What if you can do all of that in a single place and get direct access to your data? That's what Starburst does. Starburst speaks your language. So it is all in for the open table formats like Hoodie, Iceberg, and Delta Lake. So you can use the tools that are best fit for your use case with no strings attached. So for those engineers who try to run the ETL pipelines for hours and hours, fault-tolerant execution is that mode of Starburst which makes sure that your queries run reliably, even if something hiccups and the queries fail, it starts from where it left off so that you don't waste on the progress or on the resources. For those who are more used to using Python, so we have PyStarburst, through which you can actually write your data pipelines within Starburst without ever having to go after the clusters at all. So this all comes with the familiar data frame API, Python, PySpark APIs, and Starburst offers packaging on top of it. And also auto-scaling feature of Starburst helps you to analyze from gigabytes of data to petabytes of data in no time. And the best part is you can actually integrate with your existing tools like dbt or Airflow or Jupyter or Spark without making much changes on your existing data set, making it feel like the integration is just a breeze, right? And whether you're leaning towards a fully managed solution like fully managed cloud solution, you can go for Galaxy, or if you like the flexibility of having everything configured on-prem, we have the option of Starburst Enterprise. All of this comes with Starburst security and governance features that are built right into the platform. Now, let us look at what are the different data problems that we have today. So while Starburst conquers the chaos of the scattered data, the AI revolution has put forward a lot of challenges in front of us. The general purpose AI sometimes behave like how I would do on the exam day. So I would just run through the syllabus on the last day and then try to be really creative on the next day in the exam. No matter what the question is, the answer would still be the same. So sometimes the general purpose AI behaves something similar to this when it hallucinates. Right. This is because AI can't train on data it can't reach, and often your enterprise data is siloed and fragmented, and it is often outdated. And the most critical data for AI often sits into your warehouses and your and databases very well outside the reach of AI. Along with this, so we have issues with data collaboration as well. So you all are used to the AI initiatives that take really long time because they get stuck into endless POCs because the IT teams and the business teams struggle to architect and govern the data around these use cases, right? And even if these initiatives make it to the end, because both the teams are working in silos, the outputs that they give, the models that are generated out of it, often lack the relevance, trust, and real-world applicability because they were working in silos. And data governance is fractured because AI use cases involving moving your data across sensitive data across different technologies like vector embeddings, LLMs, and vector DBs, resulting in increased security and governance risks. Well, when this data comes from different sources, obviously there is very inconsistent policies applied on each of these data sources. And this further increases the security gaps that we already had and adding much more operational overhead to this. Now let's see how Starburst was built to address all of these issues. The enterprise data that you have, which is scattered and siloed across all your data lakes and warehouses, Starburst addresses this by federating the queries right to the data sources with a very powerful and massively parallel processing engine, which is capable of churning out huge amounts of data effectively. Additionally, Starburst also has built-in capabilities for ingestion, whether it's batch processing or it's streaming data. Next, let's go to data collaboration. So for AI to truly deliver the value, the team should be able to use these different data sets, work with them, share across the organization. Well, Starburst makes this possible using the intuitive data discovery tools and a simple SQL access. And also you can curate data sets, what we call as the data products, through which you can govern them effectively and share it with your teams. Finally, the data governance. So data governance is a really critical part in today's hybrid and multi-cloud environments. Starburst provides robust data features including fine-grained access control, AI-powered data generation, AI-powered data classification, data and network security, making sure that all your data is secure and compliant and only accessible for those who are in really need of it. By addressing the three pillars of data problems of AI today, Starburst enables organizations to unlock the full potential of AI. Now let's switch gears and see for a moment how Starburst can improve the outcomes of AI within your organization. Retrieval Augmented Generation, or RAG. It's like giving your AI a superpower memory boost. Instead of relying solely on the data in which the LLMs were trained on, RAG applications can dynamically query your enterprise sources and give it up-to-date and context-rich relevant information to derive the insights. Well, what this means is the AI can give you answers, not just on the data it was trained on, but on the data which is up-to-date from your organization and give you context-rich answers. This could be the secret sauce behind your smarter applications or the engine or a chatbot or the engine behind the chatbot that actually knows what it's talking about, right? It's all about grounding AI in your real world data, making sure that you get the accurate results out of it. We already established that Starburst differentiates itself in terms of the giving access to the data as of now. So now we want to build a one-stop solution that not only connects your disparate sources, but also enhances AI-powered decision-making without compromising on the quality, security, or control. Now, Let's look into two leading techniques of how to connect the enterprise data with LLMs. The first one is RAG. When a user asks a question, something like, what are the latest advancements in quantum computing? What RAG does is it goes to your data sources, your enterprise data sources, which house the critical data, and try to get the most up-to-date and relevant data for the RAG. So this drastically improvises on the relevance and accuracy of the AI-generated answers, ensuring that your answers are always up-to-date and grounded in your own data. So let's move on to the next technique, which is prompt stuffing. So a technique that leverages advancements in LLMs that can accept huge volumes of data as text. With this, you can add or send your data, enterprise data, as much as possible within the texting prompt. So when a user asks a query, summarize this research paper for me, what RAG does is it goes to your data sources, it collects all the relevant, most up-to-date data, maybe a research paper or the articles, and then it stuffs it within the prompt and sends it to the LLM. The LLM then processes the data based on the context which it got from your data, and then gives you the answers which are more relevant to you and up-to-date. So let's see how the RAG behaves and the steps involved in it. Well, the process starts when the user asks a question. In this case, what are the advancements in quantum computing, right? So when the user asks this question, the RAG application tries to go to your data sources and collect the most up-to-date data. That is, what are the recent research papers that were published, and also the articles surrounding quantum computing, right? With this data that is collected, we call it as a retrieval part or retrieval stage of the RAG. And then the next part, the RAG application tries to send this to the LLM. Before it does that, it collates all your data and with the user's question and send it to the LLM. This is called the augment part of the RAG. Next, the LLM generates the response on top of the data it just received, completing the whole cycle of RAG. Just make sure that the results that you get are more accurate, more relevant, and up to date. So, next, moving on to see how Starburst can help you improvise the questions, improvise the quality of answers that you're getting from your LLM by bridging the gap between your enterprise data and the machine learning models, right? Imagine you're a data scientist and you're given the task to run through a complex observational data and give the insights. Traditionally, what this would involve is you have to go to a data engineer, try to collect the data from various data sources and write ETL scripts just to process it, and then use another set of tools to run your AI functions on top of it. Right? With Starburst, you don't have to do any of that. You can just run it in a simple SQL query as shown in the diagram. So let's say in our example, let's say you have your clinical trials data, which is in your Oracle operational database. And then you want to join the data with the trials that you ran, which is in your Delta Lake because of the cost reasons. Now with Starburst Query Federation, you can join both of these data on the fly. I'm doing so here on the patient ID. So then I'll select the only columns that are most relevant for me, the patient ID, the blood type, and the trial ID, right? So I can call the LLM functions directly from a SQL query. The functions that you see, classify text, extract content, and summarize, these are the actual LLM functions that you can call right from the SQL. And these process the unstructured data right beside the structured data that you have. With this, we are trying to classify here using the classify function. We are trying to see how did the patients behave with the different treatments that were given to them. Is it positive, negative, or inconclusive? And once I get that, I will try to extract the NPS pain value from the symptoms, which is a list of different symptoms that the patient went through, right? And after all this, I would like to summarize and see the top 10 results. What this actually does is, given a data set of trials, it tries to identify how did the patients behave based on the different treatments they were given, based on the different treatments they were given at different pain scale, right? So this would typically involve, medics and data scientists going through a lot of data, but with this Starburst, you can just do it in a simple SQL query without ever having to leave the platform at all. So we understand at Starburst, we understand that one architecture cannot really be a solution for an enterprise. So we give you the flexibility to choose your own backend. That is, you can choose any LLM that you want, whether it's something which you have homegrown, or it can be third-party apps like OpenAI or AWS Bedrock. Now let's see how we can integrate RAG within SQL, within Starburst, right? Consider an example. You are the operational person in your office and you want to understand what is the top reasons why the dashboard was down, and how do we stop that from happening. So for this, where we start is trying to collect the data for this question. That is the support tickets that have been sitting in your platform, in your data sources. So we'll try to get the data from your support tickets from a simple SQL query, right? And the question that we have is the slow loading times on dashboard. We want to understand why is it and what are the solutions for it, right? So we are utilizing the vector search, and we are calculating the vector embeddings for each of the ticket that was generated in your system with the question that the user has, slow loading times on dashboard. And we are trying to limit it to 10 because we want only the top relevant 10 tickets that were created that was relevant to the question that we have. And then the next step is we'll create the prompt out of it. And the prompt, we can use a simple SQL functions like concat and list aggregate. The concat will try to glue in together the question the user originally had, and then we have the list aggregate, which actually collates all the results that you got from the previous stage. That is your tickets. And then from this, it is sent to the LLM using the prompt SQL function. This prompt is configured to hit any LLM endpoint, whether it's on cloud, on-prem, or it can be anything that is homegrown. So with this, the LLM will be able to give you answers which are actionable based of the data that you already have. Now, there are many ways how you can integrate Starburst within your RAG workflow. Now we can see one example of how to do it, right? You can start by collecting the data from your varied data sources and using by ETL, that is extraction, transformation, load, and chunking the data into manageable pieces. Either you can use Starburst or Spark. Like I said, we are open for open hybrid solutions. So, and then while you're collecting and running your ETLs, you can also create your embeddings based on the data that you just collected and store it as iceberg tables in your own data lake. These iceberg tables are governed. Let's call this Starburst Ice House. And then the next, when the user asks a question, it goes to Starburst AI search. What it does, it does a full vector search based on the vector embeddings that you generated in the previous step, which it has in the Delta Lake in the form of iceberg tables. And it also does a full text search because the vector search gives you the semantic similarity or understanding, and the full text search will add on top of it. And next, we try to combine these two results to give you much more contextually aware answers which are more relevant to you. And then we use the Starburst AI functions like summarize, extract, classify, sentiment, and prompt. These are the functions which you can use to call your LLMs. And these doesn't have to be on-prem or cloud. It can be anywhere that you want. It can be anything that you want, right? And the prompt tries to gather the context from the AI search also with the answers, also with the original question that the user asked for, and sends it to the LLM for generating the response. And all of it is underpinned by Starburst data governance and compliance via Starburst data products. So all the embeddings, vector embeddings, and text indices that we just generated are stored in your object storage, and which are fully governed by data products. Remember the questions that we initially had about data access, data collaboration, and data governance. Starburst solves it all. Thank you. We have much more content to share with you. Please meet us at the booth. Thank you.